Good morning, dear student. In today's lecture, we will discuss a metal catalyze liquid phase oxidation reaction. Metal catalyze liquid phase oxidation reaction. So, in previous lecture, we will discuss the Wacker process in which metal complex is used to catalyze the reaction, that is to convert the alkene into aldehyde. So, in this case, we consider only the metal ion. So, what is the role of this metal ion to catalyze the liquid phase oxidation reaction? So for that purpose we discuss two reaction. The first one is the conversion of cyclohexane in presence of O2 and the soluble salt of cobalt and manganese catalyze the oxidation of this cyclohexane to cyclohexanol and cyclohexane. And the second reaction, that is the conversion of cyclohexanol and cyclohexanone in presence of nitric acid and vanadium plus 5 and copper second as a catalyst to convert these two components into adipic acid. But if you consider the second reaction, that is the conversion of cyclohexanol and cyclohexanone in presence of nitric acid to adipic acid, it will generate certain byproducts such as nitrogen dioxide NO2, nitric oxide NO, and nitrous oxide N2. The NO2 and NO, that is nitrogen dioxide and nitrogen oxide, are recycled for the synthesis of nitric acid, but this nitrous oxide, that is N2O, it is very harmful, and it is a ozone layer depleter, and therefore the second process, that is the oxidation, the formation of adipic acid, it is not very useful. So it is a very harmful process which generates the nitrous oxide, which is a ozone layer depleter. This adipic acid, no doubt, it is the main components of the polymer, main components of to form different types of polymers, but the root, it is harmful for human being. So we are very much interested the metal catalyze liquid phase oxidation reaction, that is we are very much interested in the reaction first, that is conversion of cyclohexane to cyclohexanol and cyclohexanone. So if you consider what is the role of metal ion into this oxidation reaction, the role of metal ion in oxidation process is that it catalyzes the initiation step. What is the role of metal ion? So it catalyzes the initiation steps. So the organohydroperoxide can be reduced and oxidized by metal ion that can be easily shuffled between two oxidation steps. So before discussing the mechanism of metal catalyzed liquid phase oxidation, we will discuss, we are very much familiar with this radical formation mechanism. So for oxidation, auto-oxidation, we consider it is an auto-oxidation. Any oxidation process consists of very large number of simultaneous and consecutive radical reaction. Most of them are categorized into three basic types. So we are very much familiar with this radical formation reaction. That is, first, that is initiation, then there is a propagation, and last one is termination. So for understanding the mechanism of liquid phase oxidation reaction with the help of metal ion, we discuss some reaction without metal ions, and in second part we discuss with metal ions. So we are very much familiar with this initiation, propagation, and termination step. So what happened? Let us consider the reaction, that is organic radical initiator. It is denoted by symbol capital I small n twice. That is ion2. It is an organic radical initiator. In this case, not metal complex is used. So you should remember there is no metal ions, so and no metal complex is used for initiation process. So without metal ion we consider this reaction. The role of metal ion in oxidation process is that it is a catalyst for the initiation steps. So we'll discuss first this organoradical initiator. So this in initiation step, the organoradical initiator get dissociated to give ion radical, two ion radical, and these ion radical again react with your substrate, that is saturated hydrocarbons, that is for example RH, and then it is converted into R radicals and ion H. So this is the initiation with the help of organic radical initiator. Then in the propagation step, whatever the intermediate which is formed, that is R radical, it will react with your O2 and the formation of RO2 as a radical. Again, the intermediate RO2 radical again react with your substrate, that is RH, and it will form the organic hydroperoxide, that is RO2H plus R radical, and there is a termination step. If you want to stop this reaction, then the two molecules of RO2 radicals combine together, which terminate the reaction. So what is going on up to this? So initiator, it will initiate the reaction, it will react with substrate, it will forms the intermediate, and the intermediate react with O2, and it will again forms the reactive radical, that is RO2, and this is again react with your substrate RH, and it will convert the RH into RO2H. So this is all about without catalyst, that is organoradical initiator. It will initiate the reaction and convert the saturated hydrocarbon into organic hydroperoxides, that is RO2H. So conversion of RH into RO2H with the help of organic radical initiator. So this is without metal ion. So what metal ion is do? So let us consider the metal catalyze initiation. Organic hydroperoxide, that is RO2H. So you should remember what is organohydroperoxide, that is RO2H. Organic hydroperoxide can be reduced, that is a reduction means gain of electron, and oxidize means loss of electron by metal ions. So organic hydroperoxide can be reduced and oxidized by metal ion that can be easily shuffled between the two oxidation state. So let us consider the reaction, that is the organic hydroperoxide, that is RO2H, it will react with metal ion such as capital M, and it having a charge N plus. So it will interact with this metal ion and there is initiation. So let us discuss this process. So it will forms RO radical, hydroxy radical, OH minus radical, and the metal get oxidized. So in this case, if you consider this ROOH, it get reduced, so it having radicals, so it having a charge 1 electron, therefore it undergo reduction reaction and metal undergo oxidation reaction, that is metal N plus 1 and having plus 1 charge. In the second step, the other molecule, that is the second molecule, also react with the N plus 1 plus species, metal ion species, and then it will gives the product, that is RO2 radical plus H plus and plus Mn plus. So in this case, the metal ion get reduced. The metal ion get reduced with the formation of this RO2 radicals and H plus radicals. So this is simultaneous oxidation and reduction. So organohydroperoxide can be reduced and oxidized by metal ion that can be easily shuffled between these two oxidation states. In the next step, the RO2 radical which is formed. In the next step, the RO2 radicals react with the RH. It will also directly gives the ROOH plus R radical, that is a direct oxidation. So this RO2 radicals react with your RH substrate, and it will use directly ROOH. So it is a direct oxidation. So we are not very much interested in this reaction, but the main intermediate which is formed, that is after that RO radicals react with RH. So we are very much interested in this step, that is RO radical react with your RH, that is substrate. It will gives ROH. It will gives ROH. So RO radical, it will react with RH. It will gives ROH plus R radical. So this is all about the metal catalyze initiation reaction. So without metal ion, we use the organo initiator. It will convert this RH into RO2H, that is organohydroperoxide, and then after the organohydroperoxide undergo initiation reaction to give RO radicals with the help of metal ion. So this metal ion undergo oxidation as well as reduction, and whatever the RO radical which is formed, it will react with your RH substrate, and it will give the final product, that is ROH plus R radicals. So this is the role of metal ion. So it involves in the initiation step for the oxidation reaction. So this is all about metal catalyzed liquid phase oxidation. You should remember these two reaction, that is conversion of cyclohexane to cyclohexanol and cyclohexanol in presence of O2, and the catalysts such as cobalt 2 plus and Mn2 plus. Thank you.